Okay, good morning, children. Topic is radiation pressure. Radiation pressure means when the radiation is incident on the surface, any surface, some pressure is exerted on it. That is called as a radiation pressure. రేడియేషన్ ఒక తల మీద పడడం వల్ల దాని మీద కొంత ప్రెజర్ అనేది యాక్ట్ చేయబడుతుంది. ఆ ప్రెజర్నే మనం రేడియేషన్ ప్రెజర్ అంటున్నాము. సో if the EM wave is propagating with a light velocity, the EM wave is electromagnetic wave is propagating with a light velocity, that is c. So this is the light velocity c. Then the linear momentum of the EM wave exerted on the surface is P is equal to U by c. U is the energy and c is the light velocity. U is the energy, c is the light velocity. Now here the P is equal to energy by light velocity. This gives the momentum. Now when the radiation is incident on the surface and reflecting along the original direction. Now the radiation, this is the surface, the radiation is incidenting on the surface. When the radiation is incident on the surface, this is the radiation. Here the momentum is equal to U by c. P is equal to U by c. And if the radiation is, now the total radiation is observed by the surface, but here the radiation is incidenting on the surface and reflecting back. The radiation is incidenting on the surface and reflecting back along the same direction. This is the incident wave and this is the reflected wave. So the total momentum is delivered on the surface is equal to 2U by c. 2U by c, here the U by c, here the 2U by c. So now next one is intensity of the wave. The intensity of the wave means the energy is transferred from the unit area in the unit time. Energy is transferred from the unit area and the unit time. For example, if this is the surface, this is the as in the one surface here. This is the surface is placed perpendicular to the propagation direction. This is the area surface, and this EM wave is propagating from the surface, and the EM wave, the energy is transferred. From this surface, which is perpendicular to the propagation direction of the EM wave in a unit time, is called as the intensity of the wave. So therefore U is equal to average value into dV. So therefore U is the energy. This is the energy density and this is the dV value. So therefore energy density means energy in the unit value. Energy in the unit value into dV, you can get the total energy. So therefore du is equal to, here let's consider the small area. This is when in the dt interval of time, here the wave is traveling c into dt distance. So therefore here the area into distance, we can get the value. So therefore a into c into dt, we can get the value. So according to the definition, intensity of the electromagnetic radiation is equal to energy crossing from the unit area into unit time. Energy crossing from the unit area and unit time is called as intensity of the electromagnetic wave. That is exactly equal to, here this U is divided with A into dt. Now we can get U of AV into C. So therefore electromagnetic average energy into light velocity. Electromagnetic average velocity, average energy into light velocity is gives the intensity of the light. But what is the average value here? Already discussed in the previous study, 1 by 2 epsilon naught into E square into C. So therefore this is the uh, intensity of the electromagnetic radiation.